Hello everyone. I am Dr. M. Deepa, PG and Research Department of Mathematics, Sri Shanta College for Women, Autonomous, Salem 16th. We are going to see the topic derivatives, subject real analysis. Introduction of real analysis. In mathematics, real analysis is a branch of mathematical analysis that studies the behavior of the real numbers, sequences, and a series of real numbers and real valued functions. Some particular properties of real valued sequences and functions that real analysis studies include the convergence, limit, continuity, smoothness, differentiability, and integrability. Next, the derivatives. The definition of integral has the nothing to do with derivatives. The fact that the integral of a to b f can be evaluated by anti-differentiating f belonging in b and a. Next, the definitions of derivatives. Let f is the real valued functions on an interval j contain orders if c belongs to j. We say that f has a derivative at c if the condition for limit x tends to c f of x minus f of c divided by x minus c, the equation number 1. If the limit exists, we denote that by f dash of c. It is clear that limit x tends to c f of x minus f of c divided by x minus c is same as limit h tends to 0 f of c plus h minus f of c equal to divided by h. F is a derivative at c. Sometimes more simplified that f dash of c is the exist. For example, if f of x equal to modulus of x, my limit point minus infinity less than x less than infinity, then f of x minus f of 0 divided by x minus 0 equal to 1 if the condition x greater than 0. While f of x minus f of 0 divided by x minus 0 equal to minus 1 if the condition for x less than 0. Next, theorems statement. If the f and g both have derivatives at c belongs to R dash, then we have proved that f plus g, f minus g, fg also has the derivatives at c belongs to R dash, and f plus g dash of c equal to f dash of c plus g dash of c. F minus g whole dash of c equal to f dash of c minus g dash of c. Third one, fg whole dash of c equal to f dash of c g of c plus f of c g dash of c. Further, if g dash of c is then not equal to 0, then we have proved that f divided by g has a derivative at c, and f divided by g whole dash of c equal to g of c f dash of c minus f of c g dash of c divided by g of c whole squared. Next, the proof. The first one is f plus g whole dash of c equal to f dash of c plus g dash of c. Let us c belongs to R dash and x not equal to c, let h equal to f plus g. Let h of x equal to f plus g of x. Then h of c equal to f plus g of c. H of x minus h of c equal to the h of x, the value of f plus g of x, minus the h of c, the value of f plus g of c. Both sides divided by x minus c. H of x minus h of c divided by x minus c equal to f plus g of x minus f plus g of c divided by x minus c. The multiply the functions f of x plus g of x minus f of c plus minus g of c. Next, we have simplified that f of x minus f of c divided by x minus c plus g of x minus g of c divided by x minus c. Since f and g has the derivatives, then f dash of c and g dash of c is the exist. limit both side limit multiplication of x tends to c h of x minus h of c divided by x minus c equal to limit x tends to c f of x minus f of c divided by x minus c plus limit x tends to c g of x minus g of c divided by x minus c. H dash of c equal to f dash of c. Limit x tends to c g of x minus g of c they divided by x minus c equal to g dash of c is the equation number 1. H dash of c equal to f plus g whole dash of c equal to equation number 2. From the equation 1 and 2, f plus g whole dash of c equal to f dash of c plus f dash of c plus g dash of c is the f and g has the derivative, then c belongs to r, then c belongs to r dash, then f plus g also has the derivative at c belongs to r dash. Next one, f minus g dash of c equal to, we have proved that f dash of c minus g dash of c. Let us c belongs to r dash and x not equal to c, let h equal to f minus g. Then h of x equal to f minus g of x. Then h of c equal to f minus g of c. H of x, subtract the functions h of x minus h of c equal to h of x the value of f minus g of x, h of c the value of f minus g of c. Therefore, f minus g of x minus f minus g of c. Both sides divide by x minus c. Then h of x minus h of c divided by x minus c equal to f minus g of x minus f minus g of c divided by x minus c. Then multiply the functions f of x minus g of x minus f of c minus g of c divided by x minus c. Then simplify the functions f of x minus f of c divided by x minus c, g function of g of x minus g of c divided by x minus c. Then f and g has, since the condition for f and g has the derivatives, f dash of c and g dash of c is the exist. Both sides limit x tends to c h of x minus h of c divide x minus c equal to limit x tends to c f of x minus f of c divided by x minus c minus limit x tends to c g of x minus g of c divide x minus c. Then h dash of c equal to f dash of c minus g dash of c is the equation 3. Therefore, f h dash of c equal to f minus g whole dash of c is the equation 4. From equation 3 and 4, f dash of g f minus g whole dash of c equal to f dash of c minus g dash of c. Therefore, if f and g has the derivatives at c belongs to r dash, therefore then f minus g also has the derivative at c belongs to r dash. Next, we have proved that fg whole dash of c equal to f dash of c g of c plus g dash of c f of c. Let us h equal to fg. Let h of x equal to fg of x. Then h of c equal to fg of c. The h of x minus h of c. The h of x the value of fg of x. The h of c the value of fg of c. Therefore, h of x minus h of c equal to fg of x minus fg of c. Multiply the functions f of x, g of x minus f of c, g of c. Next one, the f g of x, f of c is the add and subtraction. The first f of x is the g of x minus g of x f of c plus g of x f of c minus f of c g of c. The function of both sides divide by x minus c, h of x minus h of c divided by x minus c. The simplification of h of f of x minus f of x minus f of c divided by x minus c. The common terms of g of x plus g function of g of x minus g of c divided by x minus c. The common term of f of c. Since f and g have the derivatives, f dash of c and g dash of c is the exist. The limit function extends to c h of x minus h of c divided by x minus c. The limit function extends to c f of x minus f of c divided by x minus c into g of x plus limit extends to c into g of x minus g of c divided by x minus c into f of c. Then h dash of c equal to f dash of c into g of x plus g dash of c into f of c. The equation 5. Therefore, h dash of c equal to fg whole dash of c. The equation 6. From the equation 5 and 6, fg whole dash of c equal to f dash of c, g of c plus g dash of c, f of c. Therefore, f and g has the derivative at c belongs to r dash. Then fg also has the derivative at c belongs to r. The fourth one, f divided by g whole dash of c equal to g of c. We have proved that g of c f dash of c minus f of c g dash of c divided by g of c whole squared. Let h equal to f divided by g and let c belongs to r dash. Then for x not equal to 0, f dash of g and g dash of g, f not equal to 0, f dash of c and g dash of c is the exist, with g of c is the not equal to 0. Then h of x minus h of c. h of x, the value of h equal to f divided by g. Then h of x equal to h of x equal to f divided by g of x. Then also h of c equal to minus f divided by g into c. The add and the subtract the value of h of x minus h of c divided by h of x, the value of f divided by g of x minus f divided by g of c. Both sides divide by x minus c. h of x minus h of c divided by x minus c equal to f divided by g of x minus f divided by g of c divided by x minus c. F multiply the functions f of x divide g of x minus f of c divide g of c divide by x minus c. The cross next one, the cross multiplications the functions f of x into g of c minus g f of c into g of x divide g of c divide by x minus c. Next we have simplify 1 divided by g of x g of c equal to into f of x g of c minus f of c g of x plus f of c into g of c add and subtractions minus f of c g of c divided by x minus c. One which equal to 1 divided by g of x g of c equal into f of x plus minus f of c divided by x minus c into c of c minus g of x minus g of c divided by x minus c equal to f of c. Then since f and g have the derivative at c belongs to r dash, then f dash of c and g dash of c is the exist. Multiplying the both sides, limit x tends to c, h of x minus h of c divided by x minus c. The limit x tends to c 1 divided by g of x g of c into remaining terms. Therefore, h dash of c equal to 1 divided by g of x g of c equal to g of c whole squared. F of x minus f of c divided by x minus c equal to f dash of c g of c minus g of x minus g dash of c equal to g dash of x minus c equal to g dash of c into f of c. Then h dash of c equal to f divided by g whole dash of c, the equation 8. From the equation 7 and 8, f divided by g whole dash of c equal to f dash of c into g of c minus g dash of c into f of c equal to divided by g of c whole squared. If f and g is the has the derivative, further if g dash of c is the not equal to 0, then f divided by g also has the derivative at c belongs to r dash. Next, the theorem, state and prove the chain rule. Statement, suppose f has the derivative at c and that g has the derivative at f of c. Then pi equal to g, then prove that pi equal to g composition f has the derivative at c and pi dash of c equal to g dash of f of c into f dash of c. Next proof, let k of h equal to f of c plus h minus f of c. Then k of h divided by h equal to f of c plus h minus f of c divided by h. Both side limit function h tends to 0, k of h divided by h equal to limit h tends to 0, f of c plus h minus f of c divided by h. F of c plus h minus f dash of minus f of c divided by h, the value of f dash of c. The equation 1. Limit h tends to 0, k of h limit h tends to 0, f of c plus h minus f of c. Then f of limit h tends to 0 is the h, the value of h is the 0, then the value of f of c minus f of c. Limit h tends to 0, k of h equal to 0. The equation 2. The first case 1, if f dash of c is not equal to 0, then 1 implies k of h divided by h not equal to 0. K of h not equal to 0, then pi of c plus h minus pi of c divided by h. The pi of c plus h equal to g of f of c plus h minus g of f of c divided by h. F of c plus h, the value of k of h. K of h plus f of c minus g of f of c divided by h. The multiply and divided by k of h. G of k of h plus f of c minus g of f of c divided by k of h into k of h divided by h. Equation 3. The both side limit function h tends to 0, pi of c plus h minus pi of c divided by h equal to limit h tends to 0, g of k of h plus f of c minus g of f of c divided by k of h. Limit h tends to 0, k of h divided by h. The simplification by dash of c equal to g dash of f of c into f dash of c. Then case 2, if f dash of c equal to 0, then it is possible that k of h equal to 0, h is the arbitrary functions. The k of h is equal to 0, then k of h equal to f of c plus h minus f of c equal to 0. Therefore, f of c plus h equal to f of c. Then pi of c plus h minus pi of c divided by h equal to g of f of c plus h minus g of f of c divided by h. G of f of c h equal to the limit function of h equal to 0, then f of c minus g of f of c minus g of f of c, the value of 0. The equation 4. If k of h not equal to 0, then f dash of c when c equal to limit h tends to 0, k of h divided by h equal to 0. The quantity of k of h will be the close to 0 when h is sufficiently small. Also, k of h is not equal to 0. The quantity of g of f of c plus k of h minus g of f of c divided by k of h is the close to g dash of f of c. H is the small. If k of h is not equal to 0, thank you.